4 years from now, you're going to have a very large amount of actors that are going to have a rather non-trivial amount of compute. Like Inflection is building a cluster of 22,000 H100s. The military guys now kind of getting into it and saying like, hey, maybe we should start racing with China. The Aurora supercomputer guy is saying like, hey, we're going to work with Intel. We're going to make a trillion parameter model, and we're going to use our big supercomputer with like 60,000 Intel GPUs to make that happen. People who are making these orders are aware of the other people also making these orders, right? The relevant actors are all aware of what is going on. The people with the most impact or chance to really do these kind of things are the most acutely aware and the most like ready to race.
I'm here with Curtis Huebner, head of alignment at EleutherAI, and known on the internet as AI Waifu. People might recognize him as the one who commented on Eliezer Yudkwosky's Death with Dignity by saying, "Fuck that noise." Can you like explain for people who are like, haven't seen that comment, like what your comment was about, and maybe like what the post from Yudkwosky was as well?
Yeah, sure. So at kind of a high level, the post that Eliezer posted on April Fools of all days is basically Miri's strategy is we're probably all going to die. Almost certainly we're all going to die. But really what we want to do is we want to maximize the sort of log odds of survival. So essentially they're saying like, do what you can to not not screw up existing alignment efforts. Do what you can to, maximize the probability of survival. But in reality, we're probably all going to die. And so, I saw this post and like, there's a bit of a misunderstanding, at least in my opinion, there's a bit of a misunderstanding about like what my comment like says and kind of the tone I took, because one thing that happened with that post that I didn't really like too much, but was maybe necessary for some people, is that the tone of the post was a very somber one, kind of being honest about like the gravity of the situation and how deep and in trouble we all are, and really that was kind of the main thing I wanted to counteract with that post, or like with my comment on that post. I actually do, to a large extent, agree with people like Connor and Eliezer that the probability that we are all toast is very, very high. However, like the way I kind of see it is that you can't sort of give off vibes that you're going to give up, so to speak, or that you're going to accept anything less than success. And sort of the reason I think that is like, I don't know if like you're familiar with sort of like the game theory kind of notion of a stag hunt. Essentially, you have two hunters, and the hunters have the choice of either hunting a stag or a hare. And if they go for the hare, there's a very high probability of success. And so they'll probably get the hare, but the hare doesn't have a lot of meat, so it's not a very big reward. If you go for the stag, though, the only way you actually manage to successfully hunt the stag is if the other hunter also goes and hunts the stag, right? And both hunters, in the traditional stag hunt, both hunters are faced with the same choice, right? So the ideal outcome is that kind of both of the hunters go and they go hunt the stag together, and then they get the stag, and then they get a lot of meat because the stag has a lot of meat instead of the hares, essentially. Both of them have to sort of trust each other that they're not going to try to go for the easier route. And I guess like my perception when it comes to existing alignment efforts is that it's like a stag hunt, except that it's not like two people. It's like you need hundreds of people to get together, maybe thousands, maybe tens of thousands, all getting together to basically solve this, solve the alignment problem. I think that because of that, at least for a lot of people who kind of understand the magnitude of it, you really can't signal something like this sort of this somber attitude of failure, even if it is very true that we're almost certainly screwed, because a lot of people are probably going to take the easier road of being like, well, we're all dead. I'm going to go on vacation. I'm going to enjoy kind of the rest of the life that I have. And so really that was kind of one of the motivations for making the comment that I did.
So what you're saying is basically like we should all go with everything we have because that's the world in which like we actually solve the problem, and and make progress. And his posts had the downside effect of like people that might like become like depressed or sad about it, and then like try to like defect and say like, if we're doomed, like I might as well like enjoy life for like a few years. And so what you say, fuck that noise, or let's try to like listen to some very like optimistic things and like do the thing. That's what you were trying to like encourage and give some like wave of optimism, right?
Yeah, and the thing is, it's important to notice too that like the post that Eliezer wrote also served like a very important purpose, right? There's a lot of people that I believe were sort of, I guess, sleeping at the switch, maybe. Like they were kind of aware of the situation, but they weren't like aware of the gravity of it. And I think that like for those people, the post had kind of would have the opposite effect, right? Of like, oh wow, okay, we don't actually have this under control, because the guys who are like their entire specialty is preventing this from happening are saying there's a 0% chance, essentially, or almost 0% chance that we're going to succeed, right? Both messages were sort of necessary to say, like, for the people that are aware of the gravity of the situation and are, trying to do something, knowing that there are other people out there trying to mitigate existential risks and still kind of going at it with everything they have, but also like serving as a wake-up call for people that may not have been paying as much attention.
So for me, the post wasn't that much about like the probability of dying from AI extinction, as it was about like how to like behave with dignity, or like not trying like too like crazy things that might have like bad effects in the long term, like second order consequences. And like if you think that like blowing up TSMC or like doing crazy thing like this might be good to save the world, then instead maybe you should consider like dying with dignity instead, and like doing the ethical things that might be like better in the long run, or in the medium run, depending on your timelines. So I guess that was like my kind of like intuition. And maybe if I want to like push back against your post or your comment, it would be like maybe try to be optimistic, but still keep the like dignity part from Yudkwosky.
Yeah, I think that's a fair kind of point. In fact, like one thing that happened after I made that comment is I had kind of a really long discussion with Connor kind of following this. And one thing that we sort of like discussed is really like, I think in the post, Yudkwosky talks about dignity as like the logarithm of the probability of your success, right? And I think there's really a fair point to be said there, that like for us to succeed, it's not going to be because like a high variance, a single high variance action was done. I think he refers to those as like miracles, but you need a lot of little things to go right and build on top of each other. And I don't think I really disagree with that too much. It's mainly the point that I'm getting at is the tone, right? And what you're signaling to the people around you who are actually trying to reduce existential risk.
And I think the tone might be like a huge factor in how we like manage to convince people to work on this. I think mostly on Twitter or on the internet, people have been like commenting on this as being like a doomer post, or like even the word like doom or doomer, I think it might be like negative long term to be like a term people use as often as they do. And instead we should like talk about like aligning AI, or building an utopia, or like maximizing our impact on the light code, or those kind of things. And I think like people like tend to like see maybe like this post or a lot of the vibe there as like maybe like too negative. So yeah, I guess like some people on Twitter have been like asking like if you had like any updates since last year or last year and a half. Like since you wrote that comment, do you have like any like new thoughts on this, or like a new perspective, or you're still like as motivated and willing to work very hard on this?
I think basically nothing has changed. I do think that the situation has gotten actually like significantly more pessimistic even than when I did write that comment.
Why?
So I think that with the release of GPT-4, there was a slice of worlds where OpenAI kind of said, okay, let's let's pump the brakes. There's a slice of worlds where like OpenAI kind of says, okay, let's stop releasing things. Let's kind of close the gates and let's take actions to kind of slow down race dynamics. And right now we're seeing sort of the complete opposite of that, right? You have, GPT-4, you have a tremendous amount of AI hype pretty much all over the place. You have a lot of different companies that are now cropping up, trying to replicate what OpenAI is doing. You have a lot of venture capital kind of flowing into the space. Generally, if you're trying to avoid this kind of further acceleration of an AI race, this is not the timeline that you want to be in.
How pessimistic are you about AI being an extinction risk? And like more generally, like what are your like timelines? How do you see the future in the next few years?
If you had to ask me for a number, I think I would say like we are 90% toast. And the reason I'm saying 90% instead of like 99.99% or something like that is mainly because I do believe that there's a great deal of uncertainty that I'm just not able to model. Factors that I haven't considered, places where I'm wrong. That's like most of the thing that is carrying me to be like, it's not 100%, but I really do think that the situation that we're in is quite dire.
So internally, when you wake up in the morning without taking into account your uncertainty, you think there's like 99.99% chance of you dying?
Maybe not like 99.99, but like, pretty up there. Like 99% chance that we're all toast. We're really toast.
Why do you think that? What was the like reasoning or like evidence for this like belief?
So I think like, where I kind of disagree with a lot of other people is I do think that like once we kind of understand how to produce intelligence and once we kind of we understand how to do it very quickly or like we to do it efficiently is really the thing. I think that it took out is really just that as soon as we had a language model that was good enough, we plugged it into every API we could. Even APIs that, we just made it generally, I think OpenAI just made an update to make it generally able to be plugged into APIs by, training it to format JSONs or something like that. So like, this is the kind of behavior where like, it's the timeline where we don't survive is what it is. So you get that and you get like a whole bunch of other kind of similar failures and you add it all up and it's like, okay, we're almost certainly toast. There's definitely room for me to be wrong about the whole situation, but it's very much not looking good.
I'm kind of like curious of like if you have any Steelman or...
Yeah, so I guess there's a couple different like kind of classes of counter arguments. So like one of them is that I'm completely wrong about the efficiency arguments. So like, you look at the total compute that is necessary and maybe you really do need like an absolutely enormous amount of compute to be able to do AGI. And as a result, like, okay, you need a full supercomputer, you need 10,000 graphics cards, and Moore's law will, just happen to peter out, right? And it is petering out a little bit already. We are kind of seeing that where we are able to run these things, but they are extremely technically, it's very technically challenging to run them at scale or in any way dangerously. So that could be like one kind of component where I'm wrong. Another kind of component where things could be, where things could go well is just like, maybe I'm wrong about the difficulties of alignment. And you can actually just get away with really simple tricks like RLHF and stuff like that. And that, turns out to be good enough that you don't really need that much more than the current existing techniques or really anything more at all, and you get a system that just in general works well. So really it's those would be kind of examples that I would reach for, is that like the ceiling on capabilities and the speed at which you can get to that ceiling is significantly lower than I thought it was, or alignment just turns out to be significantly easier than I thought it was.
And so that's why it's 90% and not like 99.99, because you have like 10% chance of like this being true.
Exactly. Yeah. There's definitely like there could be a modeling error somewhere and things work out to be significantly better.
In terms of like compute we need or like size of the models we need to get to something dangerous. So you're saying that maybe the speed or like the ceiling is maybe wrong in your model? What do you currently predict for like how big of a model do we need, or when we will get there?
So kind of like if I had to kind of give a number, I would probably guess like something like, the thing that you need is probably something really small, like 10 to the 10 floating point operations per second. Over the lifetime of a model, 10 to the power of 19 floating point operations per second, which is really not that much, right? That's like 100 teraflops for like 14090 for like 3 hours. Now you're not going to be able to do it with 4090 in 3 hours with like current algorithms. You'd probably need to do like quite a bit of optimization and improvement, and maybe you need like a slightly different computer architecture or something like that. But like that would probably be like the lower bound.
For people who are not into the deep weeds of training deep learning models, like how expensive it is to get like a 4090, and like, is it like something you can get right now, or is it like something like top companies use?
Well, I mean, like a 4090 is like top of the line gaming GPU. So like any gamer with like, I don't know exactly what the current prices are, but like it's like $1,000 or $2,000 is able to get their hands on one. So yeah, this is a level of compute that is very much accessible. A large proportion of users are people.
So when you say like the compute required to have something dangerous or something that could like maybe like disempower humanity, are you saying like for training, or are you saying for inference? Because I feel like for training, that's like not a lot of compute, right?
It's really not a lot of compute, but I still do think it's actually like, if you were to get the AIs from the future, after we've kind of had a lot of room for optimization of these algorithms, I think you would actually get something that can go from like 0 to human level in, sorry, it's not 3 hours, it's 30 hours, but in a day on a 4090, essentially, using using like the best algorithms. I think in practice, like it's probably more realistic that we're like 3 orders of magnitude higher than that, but like 3 orders of magnitude higher than that is still not that much, right? Like that is, that's 10 of them for like $10,000 worth of compute for 100 days, right? Which is very attainable for a lot of people, or like one of these graphics cards for 3 years, right? Again, that is a very small, it's not like exactly consumer level, at least right now, but assuming that we can still keep getting performance improvements and stuff like that, it will be very, very soon. It's really not that much compute. And I can go in a little bit more detail about like where I'm getting kind of those numbers and stuff like that.
Yeah. Please, where do you get those numbers?
So like these are like really cheap heuristics. Part of it is just kind of like estimates of like how much compute the human brain uses. You look at the human brain and it's like estimates estimate that like each neuron fires maybe like once every 10 seconds. And there's 100 billion neurons in there. So that's like 10 billion neurons firing every second. And every neuron is connected to
Synapses?
there are 1,000 synapses. And you say, okay, like each synaptic operation is one floating point operation. Say you make this arbitrary equivalence. I actually think a floating point operation is more complicated than a synaptic operation, but you can about get that equivalence. So you have this like rough equivalence there, and that gives you an estimate of like 10 to the 12 or 10 to the 13 or something like that. Yeah, 10 to the 13, I believe, is the estimate you get. So you get like 10 trillion synaptic operations per second, which is 10 to the 13. And then basically like what I'm doing is I'm taking that number and saying, okay, well, a human lives for like 10 to the 9 seconds over 30 years, or, that's about it. So 10 to the 9 plus 10 to the 30, or 10 to the 13 is, well, not plus, but you get the point. That's 10 to the 22 operations. So your lifetime training compute is 10 to the 22 operations. And essentially what I'm doing is I'm allowing for like, let's say whether we find like 1,000x improvement in efficiency over what the human brain can do, because we can express algorithms that the brain can't express. We can compute in ways that the brain can't compute. We can like the space of intelligences is presumably very large. And so that's how you get to the 10 to the 19 number. So like if you make the assumption of like, okay, no algorithmic fanciness, you get like 10 to the 22. And if you assume like, arbitrarily, like we'll get 1,000 times more efficient than that, you get 10 to the 10, which again, okay, like is kind of like numbers that you pull out of thin air, but like this sort of gives you a ballpark of things. And when you compare it to, existing models, like I think like GPT-3 is like 10 to the 23, GPT-4 is like either 10 to the 24, 10 to the 25. And probably like, frontier models going forward are probably going to be 10 to the 26, 10 to the 27 flops. You're really into several orders of magnitude more compute. Caveat to that is that like 10 to the 13 floating point operations per second is a very kind of lower end estimate of like what the requirement of the human, the computing requirements of the human brain. Some guys put it at like, 10 to the 16, which is 3 orders of magnitude higher. And that kind of puts you at like 10 to the 25 for total lifetime compute. Some people put it all the way up to 10 to the 18, which puts you at 10 to the 27. It's kind of all over the place. But I do think kind of the lower bound is probably correct for like, weird, vague intuition reasons. And as a result, I do think that we are in very hot water, I guess. Like we are in a very large hardware overhang, and it is simply a matter of either, we get an AGI and then after that it goes and does a little bit of recursive self-improvement, or, something similar happens. And we are very much in a situation where there is mass proliferation of human level artificial intelligence.
Okay, so I think I got the main reasoning behind your argument and kind of the main numbers. So you're saying that the main like uncertainty is about like how much compute is the brain doing, and you think like your 10 to the 13 flops per second is probably wrong, or maybe like other people have like other estimates that are like 2 or 3 orders higher.
Yeah. So like, some people will say, well, okay, a synaptic operation, a neuron is doing a little bit more complicated stuff. Or really, you're only looking at like the firing neurons. Really, you should be looking at everything. Do stuff like that, your estimates are going to go up. Depending on how much complexity you attribute to what's going on, and all of that kind of cranks up the requirements essentially.
So I still haven't read Ajeya Cotra's report fully, but I'm doing like a series of videos on it, and I'm looking at the graphs right now. And I think for the lifetime anchor, which is like how much compute is maybe like a human doing in terms of compute from like birth to death, I think the estimates point at least for Ajeya's best guess, goes from like 10 to the 29 in 2025 to like 10 to the 27, like after like algorithmic improvements and like other efficiencies. So your 10 to the 22 seems like much lower than like everything else, even like the most like aggressive things.
So I can talk a little bit about that. So I think that there's a couple things that I disagree with in the report. So I think one thing that Ajeya did is that she disagrees with me very much like a complete sign flip in terms of like how algorithms kind of play into things. So I believe that, we're not going to have too much difficulty, finding human level efficiency algorithms. And in fact, we're probably going to be able to do, several orders of magnitude better than humans in terms of algorithmic efficiency. I believe that if you look at the text of the Cotra report, and again, don't quote me on this, actually go check to see if it's correct, but I believe there's actually a multiplier of 1,000 of 3 orders of magnitude in the other direction. Basically, I'm saying let's go 10 to the 13 and then let's multiply by 1/1000th to get 10 to the 10. And they're going and saying, well, let's go 10 to the 13 and then let's go the other direction, right?
Because it's very hard to get like human level improvements.
Yeah, because like the idea is maybe like the human brain and really brains in general have maybe had a lot of time to optimize their algorithms. Evolution has probably spent a lot of time kind of optimizing things, and as a result, like we're not going to be able to in any reasonable amount of time match the quality and efficiency of human level algorithms. And another kind of thing that I believe the report did is that the lifetime anchor, when they initially had it, was predicting, or a couple of the anchors actually were predicting that we would already have had AGI by now. And I believe what they did is they did like a sort of a squishing operation where they took sort of the Gaussian estimates and they sort of like pushed them over because they said, okay, well, we haven't seen it so far. And I think that like that squishing operation is the wrong way to kind of do things. What you should be doing is you should actually be cutting off the Gaussian and renormalizing. And that produces a much more sort of pressing, like you see that we're already like a lot of the probability mass is a lot closer. So I think, and again, to double check that that's actually what it is, but at least that's what I remember from kind of glancing at the report and those kind of corrections. And I think there's a couple other things all kind of work together to lead to a significantly higher estimate. I will, however, note that I believe Ajeya initially predicted something like 2050 or something like that for median timelines, and that she has since revised her predictions down quite a bit. So, I don't actually know like what specific changes happened in her model that led to that sort of down revision, but yeah.
Yeah, if I remember correctly, in the revision there was something about being able to like have AIs that do code for you. I think coding was like a big part of like how much she thought that AIs will be able to generate value in the future, and so AIs could be like transformative sooner because of like that, like how important code is for everything we do, and not like how easy it was to do code right now. But yeah, again, like check the post for more details. And the thing you said about like squishing the distribution on the right, I think it makes sense if you're like in 2019. And AGI seems like very far away, to not like include models that predict AGI happening today was like high value. If you think it's like very far away, I think there was something about like not including models that would predict things much sooner. I haven't seen the part where they moved the thing to the right for 2025. I think it would be good to have models to like have non-zero probability mass on 2023 or later.
Yeah, and I think like this is actually like the case for me. So like I do have to like, I'm not some kind of, really good predictor. I have, previously made very aggressive kind of timelines. And, I said like, okay, maybe I think like in 2015 or something, I was thinking like, there is like a 15% chance that like by 2020 we would have AGI. And that turned out to be wrong, right? So that is like, I lose base points. I lose predictive, credibility because of that. And I think like when you kind of fully integrate that out to like 2023, where we're at now, like it's something like 30% or 40% or something from my initial like 2023 estimates, 2015 estimates of when AGI was going to happen. So, you can go to sort of look at me and say, well, like my timelines are actually like updating in the other direction, where it's like, okay, they're actually stretching out. Another kind of like fun thing to think about when it comes to timeline prediction dynamics is that a consistent predictor will have their expected value of when the timeline changes slowly increase over time. You can imagine like a toy model of this being like an exponential distribution of when you think AGI is going to happen. And an exponential distribution will have the property that, its expectation, it always looks the same. You see it with like radioactive decay of particles, where like if you have a particle and it doesn't decay for like 5 minutes, then you still expect that the amount of time it takes to decay is going to be the same. Because every time you do the Bayesian update, you renormalize the probability distribution and you get back the original probability distribution that you had. And so you do actually get this general effect where, in general, you do actually expect timelines. If you're fully updated and you're fully calibrated, you do expect your timelines to sort of get longer slowly over time before they abruptly collapse when the event actually happens. And then all of a sudden your timelines are now zero.
But you do have more information, right? You do have like more papers, more models being released.
This is a very simple model of timelines, but yes, you're obviously going to be updating on papers and new developments and all this kind of thing. So that it does kind of complicate things. Yeah.
So you said in 2015 that there was like a 15% for 2020, and now in 2023. So if you were to give your like median like 50% chance of AGI, or maybe you can give like an estimate for superintelligence, as OpenAI likes to call it now. Yeah, when do you think there's like a 50% chance of like some like super intelligent agent coming along?
So I think like if you'd asked me this like maybe a month or two earlier, I would have said like 2027. So like maybe like 4 years from now. I think that now that I've kind of seen, a little bit more information, like really recent information, I think that is kind of like my timelines have pushed back a little bit, not very much. I think maybe a year. So maybe maybe 2020. I don't know, maybe add like 6 months to the timeline or something like that. So maybe 2028 is where I would put the median right now. Just because like some very recent information is kind of maybe down revise things. But
what's the information?
I guess like I was expecting certain research to happen and it didn't happen. And that either means that research doesn't work, or it means that people are not really interested in kind of making that, the direction happen. Either way, that is kind of a positive update for timelines, because it means that, in the cases where it is kind of a dangerous research direction, people aren't really pursuing that. And in the cases where, it is a dangerous research direction, people are, it just doesn't work and I'm wrong. And therefore, the path to AGI is a little bit more complicated than I thought. And as a result, we live in a world where we have a little bit more time.
So I'm glad to know that the dangerous approaches that we will not name in this podcast don't work. How do you wake up in the morning thinking that there is, like a 99% chance that you might die in the next 5 years? So if you multiply with the 50% chance for 5 years, it's more like a 45% chance.
I think I would say like I've kind of had the time to really think about this for much longer than most other people have. So like, yeah, when it was 2013 and, things were kind of the way they were, I've kind of started getting like more and more kind of evidence about the direction that kind of things are going in. Like a lot of people are, when they see things, they see ChatGPT come out, they see GPT-4 come out like a couple months later, and all of a sudden they go from like, nothing to, oh my God, we're all going to die. But for me, it's very much more been like a very gradual process where I've been like internalizing, okay, things are more complicated than I thought. This problem is hard. I'm starting to understand all of the rough edges, and slowly but surely my probability that we're all going to make it out of this has gone down. And I think I've sort of like at least partially made peace with that. So at this point, like, I guess it's sort of like a normal thing, and it's been like that for a long time. Whereas I think for a lot of people that are like getting blindsided by this technology, it very much is a punch in the gut of like, oh, I had all these plans for what I was going to do 30 years from now and blah, 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 blah. And, maybe that's not going to happen. Whereas for me, it was like, okay, I'm probably not going to make it to, 2030 is looking real far away right now. And it's been looking real far for a while. So I think that's kind of a big contributor to me like not really being that negatively affected by it. Like there is a couple times where I'm like, it hits really, things get really real for a moment. I'm like, oh boy, we could, you get the real visceral fear that we're all toast. But like, I think I've had enough of those, and those have happened like over a sufficiently long period of time now that it's like, oh, this is just like, yeah, we're all toast. And we're all toast probably pretty soon, unless I'm wrong.
For me, that moment was like seeing everyone talk about it on Twitter more and more, and like even like the US government talking about it. And I was like, oh, it's not like some obscure thing that people talk about on the internet. People like in the real world are talking about it for real. Like at some point when you have like some like uncertainty about your own models, you're like, oh, maybe I'm wrong, maybe I make mistakes. Like I'm probably like, like in the wrong direction. But if a lot of people like seem to converge to the same belief, and it starts to like appear on TV, and your like grandma calls you and be like, hey, have you heard of this thing called ChatGPT? It's pretty good, huh? It feels more and more real, and you can like starting to feel like in a gut level. I think that's like what Robert Miles was saying, like in my podcast. Like is God is catching up with like what his model was thinking for like a long time. And I guess when you were saying that like you were predicting this since 2013, it seems like in 2013 there was like not a lot of evidence, right? There's like maybe ImageNet in 2012. Like what was like other things were like pushing you in the direction of like stuff happening fast?
So I think really like it hit me that things were happening fast around maybe 2014, 2015. In 2013, like X risk was a thing that I was aware of. And then I was like, hey, we need to be thinking about this. But I was nowhere near as pessimistic as I am. Right. Really like what started to update me was like I started paying attention to all the papers that were coming out from really all over the place. And like this sensation that progress was really fast and accelerating has been pretty much constant and hasn't really gone away for a very long time. You know, I remember all the way back in 2014, 2015 being like blown away at the rate of progress. And that sensation hasn't really left. If anything, it's almost felt like things have slowed down a little bit compared to some of the developments that were happening in the earlier years.
Do you think we're going to get like a fast takeoff with maybe like some Fuly scenario with recursively self-improvement, or do you think things will progress slower than this?
So I think in takeoff time, I think there's kind of two factors, right? So like there's the possibility of takeoff, like a software takeoff, and then there's a hardware takeoff. And I think like you get kind of different dynamics and assumptions depending on how you like make assumptions about the interplay between those two things. So like if I'm right about the like extreme potential for like efficient intelligence, I think that what you will get is you'll get everything will be mostly fine, and then you will get a very fast kind of software takeoff where the minimum requirements to run an AGI very rapidly drop over orders of magnitude because, you're able to, as you go down the number of orders of magnitude necessary to reach a given level of intelligence, the rate of iteration sort of grows exponentially because your experiments get faster and faster to run. So I do expect that like if I'm right about the efficiency stuff, that we could see like, these massive models that require like 10 to the 26 or 10 to the 27 flops. Eventually one of these kind of comes online because, maybe we're just doing things in a really dumb way. And then after that, we just have like this complete collapse as this system like undergoes very fast recursive self-improvement so that it's able to run itself on very much smaller hardware. And that could happen, I expect, on the time scale of probably like, maybe not days, but like I could easily see something like a month or something like that as being a reasonable value. Things get more complicated if I'm wrong about the software efficiency. In the case where you actually have hardware bottlenecks, now you're no longer in kind of the world of bits, you're in the world of atoms. And this is where like things kind of get a little bit more fun to think about it in different ways, because now you're no longer thinking about like, okay, how do we like lower the flops count of intelligence? It's more like, how do we get more flops in general? And the question of how you get more flops is one of like manufacturing cycles, total available energy, of replication rates. And this is where you kind of get into like the fun kind of like spectrum of like, well, okay, do we get like humans to go and build the factories to make more of the stuff that we care about, or like is this kind of a thing where you're going to get macroscopic robots building factories that we don't really understand, or is this kind of the case where like Yudkwosky is right about everything, and we get bacteria that replicate on the air, on the order of like, tens of minutes or hours or whatever. And, after an initial like slow kind of progression to better and better sort of nanotechnology, that you eventually just get really, really fast replication rate. But like kind of before then, things are sort of under control and we kind of have a good understanding of how kind of things fit in. So like my view on Takeoff is kind of a function of those two things. Like how do things work in the software world and how do things work in the hardware world? And there's a lot of uncertainty on both of those.
I think for the software world, what you say doesn't really apply for this current world where you have like one company that like trains like very large models, and maybe like a few companies, let's say like 4 or 5, training like very large models. And training takes like a long time, let's say weeks or months, right? And if we were to have like recursively self-improvement from like efficiencies that are like discovered, I would kind of like see it as like open source people doing kind of like experiments on some kind of like Chaos GPT or like some stuff online, and that they won't have access to like all the compute those like big companies have. So I feel like, except if like big companies were like launching a program being like, please find the new like improvements in how to train more efficiently, and you're allowed to like interact with your own hardware or like server to do more stuff.
Well, let me flip that around and say, like, given that there's, I think Nvidia is aiming for something like 400,000 H100s rolling off the assembly line every quarter. And there's a lot of companies that are making big orders for like, 20 to 80K H100s, right? What is your view that someone isn't going to go and just say, especially given kind of the previous circumstances where we've said like, we were talking about boxing and the way that actually turned out. What makes you think that you aren't going to get these AI systems effectively being unleashed on their own source code once they're sufficiently capable and being explicitly instructed to make themselves as powerful as possible, as fast as possible?
Because all the companies ordering like hundreds or thousands of H100s are going to try to research how to make their stuff more efficient and like run agents or run stuff in a loop. Like, what is the argument here?
So like, I guess like the thing is like, say you get the first AI that is as good as an AI researcher, and it takes like, you have maybe like 100 people in the, a couple hundred people in this company that are working on this thing, and you have like, you train it on a cluster of like 10,000 H100s. Initially, you have like 100 people that are working on doing these optimizations. But as soon as you kind of get to this human level, you have like, now you have significantly more throughput. You can actually kind of dive into the math of like, okay, exactly how many, what is the like equivalent of like simultaneous people, and it depends on like assumptions about how big you make the networks and stuff like that, and how fast you can do inference and all these kind of things. But like, I think there's going to be a lot of room. Like you're going to get a lot of, as soon as you do like the first training run, you're going to get a lot of room for a very rapid self-improvement. Just because you're going to have, quote unquote, a lot of, machine power that you're going to be able to redirect at the task of kind of optimizing the code base. And yes, there's like, there's fundamental kind of limitations there, but this is where like the question of like, what is the theoretical software efficiency and how much time does it take to really get there in terms of like man hours? And
yeah, I think it's like a huge assumption that we will get some like AI capable of doing like everything an AI researcher can do, or at least like that's like further down the line. Maybe it's like in more than like at least 3 years, possibly like 5 to 10, right? And or we can discuss the precise numbers, but I think it's very significant. The real argument is that we're going to get something like between 0% to like 100% of like can do like everything a human can do, and there's going to be like this like 1% or like 10% thing that like the AI is not able to do, and like the human we need to like jump in and do some kind of things to help like in the physical world, or like file some document for like Amazon AWS to like prove that you're a human, or like doing this like CAPTCHA, or of course, like at some point, is able to like bypass like every human thing and do everything on his own. But I'm like, my model for like why it might be later than this is like maybe the AI research is like kind of like hard to do, and there's like always like some small fraction of human labor.
Yeah, so I think it really, you're depending on your model of exactly how that human labor fraction kind of decays is going to tell you whether or not you get like a slower or a faster or like a harder, maybe not fast and slow, but like hard and soft takeoff. Because like, I think that there's a really big difference between a human being there needed for like 1% of all the work and a human being there for, 0% of the work. And it also is a function of like the amount of compute that you have at your disposal. So like if the AI is helping, humans, but like that 1% where the human is there is actually a bottleneck. And so you're only really able to throw like 1% of the computational resources to actually accelerate, your researchers. And I do believe like with ChatGPT and stuff like that right now, we're well below that, level. Like if you look at like how much compute OpenAI researchers are soaking up just to like, aid themselves, I imagine it's a tiny fraction of the amount of compute that they actually have available to them. And yeah, maybe like if you get a soft transition, it'll probably be because you're sort of saturating that compute. And you're doing AI research as fast as you can. And and more like, when I say that, I do mean stuff like that's less non-trivial than like big training runs. Um, I mean, like, actually like improvements to the source code, like actual, time being spent, writing code and making improvements and stuff like that. But yeah, I do think that like it's a very tiny fraction right now. But if we live in a world where like OpenAI manages to soak up all of their compute, helping helping the humans, and the humans aren't really a bottleneck, but they are still necessary, then yeah, I think you could make an argument that you get like a more smooth takeoff.
I guess the main argument I was trying to aim at is, unless people are like acting like really dangerously and trying like very like not very moral things, like trying to build like a self-improving AI or try to build like an AI scientist without sandboxing it, then we might not get it. And it seems like with the super alignment posts, or I don't know, like Anthropic and even DeepMind, they have this concern about like alignment, and so maybe they won't run those experiments just yet. And maybe we maybe like the open source people will just run those experiments like 3 years later when they have the compute, right?
This is why I bring up the large amount of H100s that are being manufactured right now, is that there's more than just OpenAI, Anthropic, and DeepMind now. The race has been started. Like Inflection is building a cluster of 22,000 H100s. There's rumors of like, some people doing a cluster of like 80,000 H100s, or something like that. Maybe not a cluster, but like an order that big. You have the major cloud providers. Microsoft is not, sitting around idly either. And they've kind of explicitly said in their like Sparks of AGI paper that they're kind of aiming for agency and self-improvement and that kind of thing. And then you have like, you have other actors, you have state level actors, you have, all the military guys now kind of getting into it and saying like, hey, maybe we should start racing with China. And then you have like, the Aurora supercomputer guys saying like, hey, we're going to work with Intel, we're going to make a trillion parameter model, and we're going to use our big supercomputer with like, 60,000 Intel GPUs to make that happen. I really do think that like 4 years from now, you're going to have a very large amount of actors that are going to have a rather non-trivial amount of compute. And, OpenAI and DeepMind and Anthropic, might be in the lead, and they might be able to like, be smart about not just like opening up the throttle and letting it rip. They probably have the internal discipline to not let that happen. But, if they have the discipline to not let that happen, I do expect that somebody else with a very large amount of GPUs is going to step in and pull the ripcord, basically.
I think that makes me much doomier than I was before our conversation, and shortens my timeline by a bit. So yeah, at EleutherAI, you're kind of like doing more like open source research or open source software. I don't know how much you're doing open source things, but some people are like, I've been asking me like if you had like any thoughts of like an open source versus like closed source, open research versus like closed research for those kind of things.
Yeah, sure. So I guess like there's mundane considerations and there's apocalyptic considerations. That's kind of one way to put it. And I kind of have different opinions on both of them. So like, when it comes to kind of the mundane considerations, you have pros and cons of going for like as much transparency and open sourceness as possible, right? Like, on one hand, you have, once you have a fully transparent model and you kind of know what it is, how it was trained, what went into it, that's really good for auditability. That's really good for, just kind of understanding like why, obviously we're terrible at interpreting transformers right now, but like, presumably that'll get a little bit better over time. It's just generally useful to have some level of auditability into like how the model was trained. At the same time, you have like other kind of, again, mundane kind of concerns, right? Like, how do you handle personal and private information? You have an open source language model that has, during its training kind of hoovered up some information about certain individuals and effectively sort of like synthesized a lot of that as part of its training. How do you handle that? So yeah, that's kind of like the mundane stuff. But I think probably the more interesting thing that you want to talk about is the apocalyptic considerations. And there it's a little bit more, yeah. And there it's a little bit more, it's a little bit more tricky. I think that probably what you want is really you want sort of a kind of maybe not like a bimodal thing, but you want a policy where there's a ceiling on what you're willing to, the level at which you're willing to kind of open source. Small models, having them open source, it makes it possible for companies, individuals, and everybody else to kind of study them. But really, like once you get to the really dangerous systems, the systems that that can end the world, and even like you do want to have like a buffer margin essentially between the systems that end the world and the systems that don't. You really don't want those to be open, because like if you have something that can destroy the world and you distribute that to everybody, well, that ends the world. Right? It's not that complicated.
So shared models that can help us get a better understanding of how neural networks work or how transformers work. But whenever you get to like very dangerous models, maybe try to like not share it on a AGI.exe file.
Well, I would even go further than that and say like those models should not exist, right? Like if you're making a system where if it leaked out, it would be a complete disaster, you shouldn't have that. And you shouldn't have that for two reasons. One is that your own internal security is only going to be so good. And there will come a time where there will be a security incident and those weights will get leaked and you will lose control over the situation. The second is that as soon as something like that exists, as soon as something like GPT-4 exists or GPT-3 exists, and it's behind a closed door, people do not trust each other enough to be able to like have one single party trusted with control over a very powerful AI system, right? Because you can be cut off from that capability. There's also like just like a lot of people will ask like, okay, whose values get represented in the AI? They will go and say, well, okay, you're doing this with it. I don't trust you. I want my own that has its own values and lets me do this and that. And just the fact that you have it and just the fact that it exists is going to motivate a whole bunch of other actors in the space to try and do a replication effort. And that's effectively what you're seeing, or at least in my opinion, that's what we're seeing a lot of right now.
So yeah, those kind of like concerns we're raising about open source models, is it related to like things like Llama, where like people like accelerating on like making those models like better, more efficient, bigger, or are you talking about something else?
I think that's definitely part of it. It's more than just, I would say, like Llama. It's just the general like, every other country is kind of noticing these things. The U.S. government is noticing it. Everybody sees that someone has a capability that they don't, and they will make efforts to try and close that capability gap. Whether or not they succeed is another thing. Whether or not they have the budget to be able to do it. The thing though is that the motivation is now there, and that itself is concerning, at least in my opinion.
Yeah, I agree. It's like concerning that like governments are paying more attention to it. And yeah, definitely like if you're paying attention to it and listening to this podcast, you're doing the right thing. People might be interested in you, like what's your background, like how you got into this like whole like exit risk from AI thing or like deep learning thing. Like where did Curtis learn to like do like alignment work or like deep learning research?
I guess on my end, my background kind of is a very informal background, but it goes back a long ways. So like the first neural network that I wrote, or kind of machine learning I wrote, or algorithm I wrote, was like back in, I think like 11th grade, like almost a decade ago. So like, I think I was really kind of introduced to Yudkwosky's writings probably around like 9th or 10th grade or something like that. So probably 11 or 12 years ago, something like that, 2011, 2012. I do actually remember giving a talk about like effective altruism and existential risk back in like 2013 at like a small like gathering in a place in Canada called Saskatoon in Saskatchewan, which is the middle of nowhere.
Is it
But
is this where you're from? Canada.
yeah, I'm from Canada, originally Edmonton. But yeah, essentially, yeah, I have been kind of following this for a very long time. And then since then, I've been kind of, reading papers and, playing around with just, small neural networks, doing little experiments here and there. I did go on to kind of do some internships in bioinformatics. But, the extent of like my formal training it is not actually that large. It's all sort of been self-taught.
Right, and I guess that's the best way to learn how to do this thing. Everything is so recent, right? Did you first like learn how to like train big models while helping out with like those GPT Neo, GPT Neo X, or like parallel research projects at EleutherAI, or did you arrive later?
So I actually didn't have much of a hand in the Neo and Neo X models, but I definitely did pick up a lot about distributed training just from hanging out in the EleutherAI Discord. I learned, quite a lot about everything from, how the low level kind of the GPU operates and the importance of the memory of memory bandwidth and, vectorization, all that, all the way up to kind of, the various parallelism strategies that we use in large scale modeling or large scale training today.
Yeah, and now you're like working with EleutherAI on alignment projects, right? Like head of alignment for like all the different projects that are going on. So maybe can you like give like an overview of like the different projects that are currently being done there?
Yeah, so I can talk a little bit about a few of them. So like one of them that I'm kind of excited about is a collaboration that we're doing with the AI Safety Initiative at Georgia Tech. And we've kind of got two sort of projects that are going on over there. So like the first one is looking at language models kind of as Markov chains. And I don't know how familiar you are with Markov chains, but basically the idea is that you can sort of view a language model with a limited context window as sort of having a state, where the state is the entire context of that language model. And then you can go and ask yourself, okay, what is the transition distribution from like one state, so one context, to the next state? And you can look at it and say, well, okay, we add one token by sampling, and so the distribution from the one state to the next is the log probabilities outputted by the language model, and then after that we pop off the last value from the state, like the last token that pulls out of the context window. And when you take that kind of view of what the language model is doing, what you can do is you can go and say, okay, you can ask yourself questions like, what is the stationary distribution of this Markov chain? So like if you run the language model autoregressively, continuously generating new tokens and then, sampling and producing, what is sort of the distribution of text that you're going to see kind of in the long run? Another question that you can ask yourself is like, what is the quote unquote reverse Markov chain or reverse process? So if you wanted to reverse the dynamics in time such that you append a token and then you pop off the, append a token at the back and kind of pop off the back token, what kind of distribution do you get? And, it's kind of like, the first question you ask yourself is like, what does this have to do with alignment? Right. And I guess like from my perspective, it's mainly that it is a largely unexplored domain and seems highly relevant to just understanding language models as we currently use them. The reason for that is because like when we train language models, we really do use sort of like the next token prediction objective as the base. Like obviously there's RLHF that comes after that. There's supervised fine tuning that we do, but really a lot of the meat of the training is all focused around this sort of next token prediction objective. And there's a little bit of reason to believe that like when you kind of run a language model for an extended period of time, or really any sort of model that has been trained on this kind of next token prediction objective, you will kind of get a little bit of error that piles up. Eventually like the model will mispredict something, and then now its input distribution is a little bit off from what it was kind of initially trained on, and then things kind of start to snowball from there. Another kind of example of like like where this sort of failure mode is already sort of manifesting itself is, or at least like this is me speculating, but Bing, when it came out, initially sort of you could keep talking with it, going back and forth as much as you wanted, and it pretty quickly kind of started going off the rails, right? But the solution to that was, okay, let's go on, limit the length of the conversations that you can have with Bing. And obviously I can't say exactly why Microsoft did that, but I do suspect that at least part of it was because of the model kind of starting to go off the rails. So I guess like that would be sort of like an early manifestation of the kind of worries that kind of I have in mind when it comes to like this.
Are you trying to like see what is the like stationary distribution of that Markov chain of like where does the model go if it like starts to like output like very long paragraphs of text, and at some point it will like reach this like bad behavior? Are you trying to like get to this like bad behavior at the end?
So not really. We're just trying to see, like, we're not even going that far. We're just trying to say, like, how does, like, where does it go at all, right? And then, questions like, what is sort of like the mutual information? Like, how does, does it starts with one topic? How does that kind of change over time? Do you get like a, distribution shift, and sort of, how long can you stay on the same, same kind of track, so to speak? So just these really basic kind of low level questions is where we're at. I think recently the focus has actually shifted from that, and kind of asking on the reverse side now, like if you start with like a bad, kind of a bad output or a bad state somewhere that you don't want to be, can you sort of like work backwards to say like what was the chain of events that led you to that bad state according to the probability distribution specified by the language model. So that is sort of like, it's a very sort of exploratory kind of direction. If you have to ask me like, okay, how is this specifically going to solve like, one of the alignment problems? I'm gonna have to say like, it's not that is not where we're at. I do definitely think that like having more lenses and kind of perspectives to be able to understand these systems is going to be useful in general. And that maybe we're going to get to like another part later down the line where we say, oh, well, this lens is useful, or this, is a precursor to a training technique that would, mitigate some failure mode or another.
Yeah, I definitely agree that like it's good to like do like specific experiments to like inform like bigger theory on alignment, and or like other projects that like could like help like focus on like specific things. I think it makes sense to like zoom out a little bit, and maybe for people like who don't really know what's the like main goal of EleutherAI or EleutherAI alignment team like is, because I think some people like might think of like academia as having like professors trying to like publish papers or like doing research for like a lab or something. And in some sense now I think EleutherAI is like a non-profit, so maybe like some people like donate, and then EleutherAI does like research in some sense. So yeah, maybe like a better like overview or like introduction to like how is it like to do like research at EleutherAI or an alignment, like what does it mean, like what's the goal, and like what is it like to do like open source stuff with like other people that are, and I don't know, like maybe like full-time employees or.
Yeah, so I guess I could speak like just generally about Eleuther, because like, okay, we have like alignment and we have interpretability and stuff like that, but really the lines do get blurred. Really like Eleuther tries to do all like stuff that is basically we think the stuff that we think is sort of like net value, right? And that can be kind of anything, right? If we think that there's some interpretability research or some paper that makes sense to publish, we'll do that. If we think that there's like an alignment problem that it makes sense to kind of tackle that other people are not really, spending a lot of time on, we'll focus our resources there. And it also kind of extends to kind of more like mundane things, right? Like one thing that I'm less familiar with myself, but is also kind of part of Eleuther is multilingual work. So like a lot of current language model development is very much focused on English. That is sort of the dominant kind of the dominant language for these language models. And there's also like, there's a whole bunch of other languages that don't get the same level of attention. And so at least partially, Eleuther does see like a really valuable opportunity there of like, hey, this is the kind of thing that really isn't going to like, increase our knowledge of how to build, AGI and shorten timelines. But is definitely something that is going to kind of bring mundane and kind of, valuable utility to communities that otherwise wouldn't have it, right? So that is like the general vibe there is like, we're going to make sure that we don't make the situation worse. And if we see something that we think is a good idea to kind of pursue and to spend our time and resources on, we're going to go for it, whatever that might be.
From what I know about the like multilingual project, there's like a guy like leading a team like every week or like in the past like year or so, like doing like Korean language modeling or something. And correct me if I'm wrong. I might be wrong. And I guess like he like started by doing the thing by himself and like having people come and then they like started the project. But it's like like very informal at the start, and now it's like maybe like more organized. If it's someone like listening to this or watching this wants to, like work on alignment project at EleutherAI or like just like contribute to like open source, is there like any like best ways to like reach out to you or like get started? Like, do you have like shovel ready stuff to do these like Markov chain things, or is there like other projects that are like maybe like easier to get started with?
Yeah, we do have an email. You can kind of email us at contact@EleutherAI or just Curtis@EleutherAI if you're interested in talking to me specifically. But generally, the primary method that everybody gets involved with is through Discord.
And like for this like particular like Markov chain project, how many people are working on it, and is there like a need for like someone else to do something?
I think right now we're pretty full on that project. I think there's like 5. Can't remember exactly the exact number, but I think it's like 5 people. And they're kind of they're sort of working at it. Again, this is from a collaboration with the AI Safety Initiative at Georgia Tech. So they're at least partially kind of handling the management and stuff like that of that at least that project. But just in general, like the way Eleuther, especially the Discord itself, is actually structured is that we have like a whole bunch of project channels. And so like what I would kind of recommend if someone wants to kind of get involved is like, just take a look at the project channels and see kind of what people are talking about, see like which research leads are sort of active in there, and then either like make a general post in the channel itself, or go and DM whoever like the active researchers are for the project if you want to get involved. And even just asking for the like the specific project is probably the best way to kind of do it.
In terms of leading, you're the head of the alignment MineTest projects, right?
Yes, that's correct.
What's the alignment MineTest project and why is it useful?
Yeah, so the high level kind of like long-term goal, there's like a lot of kind of like intermediate sort of directions that we find is kind of interesting, but like the main thing that I want to study is I guess you could say it's like embedded agency failures in a toy sandbox. So like what do I kind of mean by that? If you look at like if you just punch in reinforcement learning into Google Images, you will get this diagram, the same diagram, a bunch of different variations on the same diagram that has like the agent on one side and that has the environment on the other. And there's this like really solid boundary between the agent and the environment. And you have actions going from the agent to the environment, and you have observations and rewards going back to the agent, right? Unfortunately, this is not how the real world works. Agents in the real world are embedded in that world, right? And a consequence of that is that you like architectures and designs that would work fine in the the standard sort of reinforcement learning setting are not necessarily going to carry over to the embedded setting. And there's certain kind of failures that we expect to be able to see and demonstrate when that happens. Like the really classic one that is less relevant because of the current techniques that we have, RLHF and stuff like that. But it's still kind of something that, is worth kind of keeping in mind as an example is wireheading essentially. And this is essentially what happens when a neural network or an agent is trained with reinforcement learning and a reward signal. And it gets sort of smart enough to realize that the thing that it is getting reward, like it's not being rewarded for, for whatever it is that we are giving it reward for. It's getting reward because the little reward circuit is being activated, right? Or like, you could imagine like a setup where like a human has a robot and, the robot is kind of going around and, when the robot does stuff that we like, we press a button and we give it some reward, right? Well, eventually the robot's going to get smart enough to be like, hey, wait, what happens if I press the button, right? That gets rid of the human and starts pressing the button itself, so it gets infinite reward, right? So that would be kind of an example of like this sort of an embedded failure. That is a very simple example of the kind of failure that we're looking for. There's significantly more kind of complicated failures that you can get with like really any sort of value updating scheme. And that is sort of the long-term goal of the MineTest project, is that we want to be able to sort of sandbox these scenarios with an AI that is like ideally like sort of as weak as we can make it to still sort of isolate the sort of embedded agency failure that we're trying to target, so that we can then like understand the failure, so we can, sort of get some idea of like, okay, how does like the value function for an RL agent evolves when it starts to notice that there's this kind of failure mode happening. And then like once we've kind of isolated that failure, then we can start to ask ourselves like, what kind of techniques can we develop to mitigate or eliminate that kind of failure?
So having some kind of like RL agent in an environment like Minecraft being embedded in the world and having a failure mode where he starts hacking his reward, assuming his reward was like inside of Minecraft. And
well, that's exactly it. Yeah. So the MineTester project, one of the like motivations for using MineTest instead of like Minecraft or existing models is because like we wanted to have as much flexibility in terms of like, programming things or implementing different, implementing stuff in the environment. So you could actually see like, okay, let's put a button in the environment and let's have a player control the button and let's have the agent also be in that environment. And let's have let's actually just do the experiment and see like, under what circumstances does the agent kind of wise up and say like, hey, I can maybe just get rid of the other player and I can press the button myself. This is kind of the type of failure that we want to be able to investigate, that we want to be able to replicate, and that we want to be able to mitigate in the long run. Obviously the project is not quite there yet. And sort of like we're going on, kind of intermediate tangents. So I believe like in the first blog post, what we mainly outlined was, we trained a basic PPO policy to kind of punch trees. And we said, okay, well, this is a really simple policy. Can we do some basic interpretability on that? What does interpretability on an RL policy look like? What does it feel like? Do we kind of bump into problems that we don't really bump into in kind of other, other kind of environments or like other sort of training settings? And there's a little bit of that that we've already sort of run into, and that we're kind of starting to think about like, what is the best way to kind of get around these sort of limitations? Like a good example of this would be like, you incentivize the model to go and punch trees, right? Or punch wood. And one thing that you would expect as a consequence of that is that the model would go and punch, it would punch all of the logs in a tree, and that would be that. But But what you actually end up seeing is a situation where the model kind of learns a strategy where it doesn't punch out the bottom log. And instead it, punches out the log above it and then sort of hops on and then is able to access kind of more logs at the top of the tree. So like if you're kind of a reward designer and you maybe want to go and like get rid of all of the entire tree, that is sort of like an unexpected or unintended kind of consequence. So one of the things that like I am currently thinking about is what is a good way to sort of detect these sort of unintended consequences of the the rewards or the feedback that we give, and how does that translate? Like right now, obviously we did basically like reward shaping and manually specifying reward function, but like what is the analog of that with something like RLHF? So these are all kind of like questions that are sort of hovering around in my mind.
And so in your project, you have this thing with the log when it's like an expected behavior. What's the next step? What's the next thing you're trying to observe?
So right now we're kind of putting aside the PPO policy for a little bit, and we're going to try and focus on like model-based RL. And kind of the next step to enabling that is just training models, generative models of MineTest, and seeing what can we understand about those generative models, because like there's language model interpretability, right? There's vision model interpretability, there's RL policy interpretability. And each of them kind of has like their own kind of unique challenges and unique strategies and stuff like that for getting places. And I do expect that like, a video model or like a model that actually also has like action outputs is going to like represent, I expect to see things like causality. I expect to see things like tracking state. Like if you see a tree and then you turn to the left and then you turn back, presumably there's going to be some machinery inside that generative model that is tracking the state of like whether that tree is there. So questions like, okay, how do you look at like state tracking inside of inside of a video model or a video model augmented with actions? How do all these kind of things interact with each other? That is like the next step that we're taking with the MineTester project.
So is the basic idea to like see if the the estimates from the agent of like how much like reward he's going to get in the future like gets like higher when he sees like a log, or like when he sees something, like when he detects something in the video, like saying like how the value function he has like changes over time with like different inputs.
So that's like one direction. I would say like it's even a little bit like that would be kind of later down the line. We're not even really like we're not really going towards the full model based RL yet, right? The way that we're kind of going to approach this is we're going to actually just have users, play the game, and then after that we're going to take that data along with like some pre-training data, and just build some basic models of the environment, and just saying like, okay, forget about value functions, forget about policies. Let's just focus on like this one subcomponent of the agent and what can we kind of get out of that.
On the website, I think it says that you're like trying to build some gym like environments. Is it done, or is it still in the weeds?
It's out of date. We have the environment. Obviously we needed the environment, so we were able to actually train it. The next kind of step, and it's not that big of a change, we'll probably get it done pretty soon, is that we're planning on collaborating with the Farama Foundation, and they maintain an updated version of the gym environment, along with like I believe like some multi-agent APIs. So kind of another kind of place where there's work to do, and is also on the roadmap for the project is support for sort of these more modern APIs essentially, and just swapping out like the old OpenAI Gym API. But we've had an environment working for quite a while now, and we've used it to train some agents, and we've done some interpretability on the policies that are learned. That's been the website is a little bit out of date.
If I'm like a deep learning or RL engineer, like listening to this, and I'm kind of like interested, what kind of like compute do you have for this, or do you just like how big is the model? Is it like just like a standard size model for like this kind of like video processing and like to have PPO on top, or what kind of like model are we talking about?
It's tiny. It's a very tiny model. The one that we trained. It's like I think we outline it in the blog post. It's like 3 convolutional layers, a fully connected layer, and then like an action and critic head. It's a very tiny neural network. Scaling things up, I do imagine, is going to make the interpretability significantly more challenging. I think like one thing, like another kind of thing that came out of it is like you can have a functional policy, but it's relatively difficult to like, especially as you kind of scale things up, you get like more noise in the system. Like one thing that we noticed is like the learned policy is really not that symmetric, but it works anyways. So like, you're thinking, well, the environment is mostly symmetric. Maybe there's a little bit of a change with like, the textures being oriented one way instead of the other, but like it's not enough to explain what's going on. And I think it's just like an initialization noise and RL noise and all these kind of things that are sort of conspiring. And the net effect of that is that you can get a very noisy, very not great policy that doesn't have very clean internal representations, but it will still get the job done. It will still kind of execute, execute a policy that actually does work in the environment.
I was going to make the joke that maybe in the Minecraft environments, because the character has like a sword or like a tool on the right, maybe that's making like the image not symmetric.
Well, you see, you can test that by like mirroring the. I mean, that's actually, that could actually explain it, because obviously like during actual training, that's not what's going on. So that, that could actually be what we've seen. But yeah, that is just generally, we just haven't seen the symmetry. So that could be what's going on.
So yeah, another thing that like you mentioned in the blog post is that the main goal is to understand corrigibility. So how to make models more likely to be corrected by humans. Like, can you say more about like what corrigibility is and why you're interested in these projects to like help with it?
Yeah, so corrigibility is the ability to, well, I mean, as the name implies, to be able to correct agents and models after they've been deployed, or I guess even during training, depending on like what assumptions you make. But really just being able to say, hey, no, don't do that. I want you to do like Y instead of X, right? And like, in the RL case, you get a really serious corrigibility failure where the agent, in the button example, going back to that, the agent going in and just like, getting rid of the human and then just pressing its own button, that's like a failure, but it's not really a corrigibility failure. A corrigibility failure is one where like the agent wants, like, say you instructed to go cut down some trees. The agent wants to go and cut down some trees. And maybe you change your mind and you say like, well, I don't really want you to be cutting down trees anymore. I want you to be doing something else, right? A corrigible agent will let you go and modify its source code, or like, give it whatever, use whatever reward mechanisms you have, or whatever mechanism really you have to edit the model, to change that behavior so that it stops doing the thing it's trying to do, or it's originally trying to do, and kind of moves on to doing something else. And this is a little bit like unnatural because, well, if you make an agent that wants to cut down trees, it's going to naturally reason, well, if the human changes his mind and doesn't want me to cut down trees anymore, well, maybe it's even smarter than you, and it sort of like sees this happening before you even, are aware that you've changed your mind. Maybe it's going to go and like throw some obstacles in your way, or maybe it's going to deceive you, or maybe it's going to do like one of a many, a bunch of different things so that it can keep doing its tree cutting, and you're sort of, cut out of the loop essentially of deciding what it does next. And so a corrigible agent is one that has that, at least in my kind of understanding, is one that has that property of, it will go, and if you change your mind, it will go along with your change of mind.
In some sense, like the agent is like trying to do what is best for you, and like tries to like check if you want to turn it off or not, and he's not trying to like prevent you from seeing what's going on. And I think it's like pretty hard to get. I'm not sure if there are like any examples of agents like preventing like humans from seeing what's going on like in real life, or if it's mostly like toy experiments right now.
So that's the thing, right? Is I believe at the moment most of the demonstrations or kind of like analysis that you have are either like, very simple decision problems like the off switch game, where there's like theoretical analysis of, if the agent believes X, or, you make certain assumptions about the agent's beliefs about the player, or you specify a certain training setup, then you can get a theoretical analysis of like, okay, under this assumption, you get this behavior, under that assumption, you get that behavior. And then like, the level above that is like grid worlds. So I'm aware of like off switch grid worlds where like a user has an off switch button that turns the agent off and prevents it from continuing to do what it was previously doing. But anything more sophisticated than that, I am not aware of anything like that really existing.
I think just like people that are like watching this might not know exactly what is the off switch game. Can you just like explain what is this game?
Yeah, so I mean, like at a high level, the off switch game is really like a simplification of kind of the more complicated example that I put, where it's like the agent is doing a thing and there's an off switch, and when you decide that you don't want the agent to be doing the thing, you press the off switch, and the agent won't try to interfere and prevent you from pressing the off switch. Might not be exactly that. My recollection of the details of the off switch game are a little bit fuzzy. I'm more just aware of like, this is like the simplest example of corrigibility that I'm aware of. I believe it's Dylan Hatfield Manel is probably the words you want to Google with regards to the off switch game. I think there's a paper on it from like 2016 or 2014 or something.
And I think like they model it as like some game theory experiment, and maybe there's like some way of like knowing exactly what's the like optimal values you give to your agent so that it accepts to like be corrigible. Yeah, how excited are you about like like finding this corrigibility inside of a Minecraft environment or like MineTest?
So I think we're going to be able to fairly easily demonstrate the failure modes that we're looking for. Fixing those failure modes is kind of another story entirely, and especially being able to do it reliably seems like it's going to be quite a challenge. I have like some vague intuitions about ideas that I can't really articulate yet about how to kind of go about actually tackling the problem. But nothing that I would say is super concrete. And I think that it's probably better to wait until we have like a solid demonstration before we really start thinking or like, deploying things, because what's going to happen is we're going to get an implementation, and we're going to get some data, and like whatever, at least some of the assumptions that I'm kind of making right now are going to be proven wrong. So yeah, that's kind of like where we're headed right now.
I wonder like how hazardy it is to like post something about race.
I think the cat's out of the bag on that one.
The people who have the 8,800 GPUs order, they probably know what's going on.
Yeah, again, the people who are making these orders are aware of the other people also making these orders, right? This is nothing. The relevant actors are all aware of what is going on. In fact, that is part of like what makes it so, terrible, is that they are very, the people with the most, impact or chance to really like do these kind of things are the most acutely aware and the most like ready to race, right? Because if they weren't racing, they wouldn't be trying to raise $1 billion to build these giant supercomputers so that they can build AGI, right? So yeah, that is yeah.
It was a pleasure to have you. Do you have like any last message for the audience, for EleutherAI, the world, the machine learning engineers, the people ordering GPUs online?
Come hang out in our Discord. Come hang out on Off Topic. Say hi to the people there. Yeah.
Coming out on EleutherAI. Thanks. It was a pleasure to have you. Have a wonderful day.